opera. I don't know why. Okay, so so you've seen a cube, okay? You've seen a cube. You know what a cube looks like? That's a cube, okay? You can make a sketch of it. This is a cube. You know what a cuboid looks like? Cuboid is a little bit, a cube is a cuboid with all sides equal, yeah? And I've shown you a cylinder. Okay, so that's a cylinder. You can draw this one. This is a nice one to draw. So you can draw this one if you haven't drawn it already. Then now this is a sphere, okay? Sphere. And that's what this sphere looks like. If you want to draw it, you can draw this one. Okay, so make a round circle and make a little curvy diameter around it, and then another one with dashed lines. Yeah, I'll sketch them all for you, but I wanted you to see them because I know that maybe you know them, but you know them in a different language. Okay. And a pyramid. Okay. So, of course, you all know what this one is. You have this ones in your country. Or is it Egypt? Yeah, you have this one in Egypt. So you know what it looks like. It's a pyramid. Okay. So if you wanted to draw, you can draw that one. And we use the base to name the pyramid. So this is a square-based pyramid, okay? It's a square-based pyramid. You can have a triangular-based pyramid as well. Triangular-based pyramid. So there we are, is that one. You see the base is a triangle, yeah? So not the other one. You can have a pentagonal one, I think. Pentagonal pyramid. So it's going to have five sides on the base. There are 5 corners on the base, yeah? So the name depends on the base, yeah? So you can have triangular, square based, rectangular based, octagonal pyramid, pentagonal, and so on. So those are all the basic 3D shapes. I'm going to make a sketch of them now on whiteboard. If you haven't drawn them, you can draw them quickly for me. Excuse my drawing. Did I show you guys a cone? I don't think I did. So this is a cone, okay? The ones you see on the traffic, like on the roads, when they are doing construction work on the road, they put the cone on, yeah? So this is a cone, or the one you have on your ice cream cone, yeah. And this one would be a sphere. Excuse my drawing, guys. Okay, this is a pyramid. Well, it's a square-based pyramid, okay? Square base pyramid. Oh, make a sketch of all of those things in your book, okay? Make a sketch of them. If you didn't know them and you're learning about them for the first time, then let me know when you finish, okay? Have you guys finished drawing? So we are so quiet. Yes. Okay, thank you. Thank you, Rim. Those of you who are responding, thank you. So you guys have not heard anything about your results. I'll check on Andrew, no. But he said you haven't heard?
No, we haven't.
No.
Oh, okay. Who is writing here? Let me see. Let me find out whether he's messaged me. Inbox. I have set up the format module. It would be a good idea to let them take their seats in a few weeks while the module is fresh in their minds. They will schedule it for a Friday afternoon so that they don't miss any class time. I have set up the further maths module. With regards to the students that failed foundation maths, I think it would be a good idea to let them take their resits in a few weeks while the module is fresh in their minds. They could schedule it for a Friday afternoon so that they don't miss any class time. Okay. So that was sent yesterday. Okay, that's great. They want to know when it will be published. When the results will be published. Okay, so I've asked him, all right, guys, we'll wait for him to get back to us, okay? I need to take this off now before it stresses me out in my eyes. Okay, stop share. So the next thing that we're going to have a look at now is let me share my I'll get rid of these ones now. Yeah, faces. We're going to be looking at okay. We're going to be looking at pyramids. Yeah, we're going to be looking at pyramids, and the way that we describe pyramids, or the way that we identify them, is through the faces, the vertices, and the edges. Yeah, so let me do the presentation for you guys so that we watch it together. Okay, so 3D shapes are defined by the number of faces, edges, and vertices. So this would be the edge. Yeah, this right here. If we were in class, I would have shown you one that I have in class. And this would be the vertex where the lines meet in the middle. There would be the vertex of the vertices, are lots of them. And the face is the face of the shape. Yeah, the face of the shape, like as in, if this is a cuboid now, this would be the face, this would be the, can you guys see?
No.
You can't see. Nobody's talking. It's so quiet. Oh my goodness.
No.
Can you see it now?
No.
No. All right. Sorry, guys. My fault. Okay. So so the way that we describe 3D shapes is through the faces, the vertices, and the edges. Okay. The way that we describe it is through the faces. Let me pin myself so that you guys can see me first. So you would have this is the face. Look at the picture of my video. Okay, this is the face. This is a cuboid. It's a matchbox. A matchbox would be a cuboid. Yeah, and this would be the face, this face, this face, this face, and this face, and the other faces on the sides. And this would be the edges on the edges there. Yeah. And then this would be the vertices where the lines meet in the middle there. That would be the vertex. Okay. I know it's very dark in here, but okay. So that's it. Let me present that to you guys. So you got the edge, the edges, the vertices, and the faces on your 3D shapes. And this is a tetrahedron. Yeah. This is what we call triangular base pyramid. Yeah. So 3D shapes are defined by the number of faces, edges, and vertices or corners that they have. Yeah. So a tetrahedron is a pyramid with triangular faces. This one has all triangular faces. Yeah. Why is my video flicking? Let's see. So here we got 4 faces, 1, 2, 3, 4. And how many edges do we think that this one will have? How many edges? How many edges, guys? This is now the time we have to do the work.
3.
It will actually have, this is 1, 2, 3, and on the bottom it has 4, 5, and 6. Let's see. Six edges, okay? How many vertices, guys?
4.
4. Well done. Even the slide is not working. Okay, now you have a square-based pyramid. I want you to draw that shape. Write the number of faces, number of edges, and number of vertices, and then we'll check, okay? I'm gonna give you, let me go get my timer. I'm gonna give you 5 minutes to do that. Oh, there we are. I was looking for it everywhere. We cannot send them out today. Okay, we can send them out today via Moodle. It might be worth mentioning to those that failed or got a low marks that they will have a chance to resit the exams. Okay, so okay, that's great. I'm just going to answer them. Okay, that's great. Okay, that's great. If you let them know, if you let them know, do you want me to? Okay, that's great. Okay. I'm just going to leave it there. I don't want to talk anymore. Okay, so who has written? So 4 faces, 8 edges, and 5 vertices. Okay, let's see, Naji. Well done to you. Yeah. We got how many faces? Let's see. 1, 2, 3, 4, 5. 5 faces. How many edges? Let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Is it 7 or 8? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. I think that's 8. Yeah. 8. Yeah, well done. And how many vertices? 1, 2, 3, 4, 5. Maybe 5. Let's see. 1, 2, 3, 4, 5. Okay, right. So Andre, let me just talk to you guys for a second before we continue any work. So Andre has asked me to tell you that your results will be on Moodle right before the end of today. Yeah. So if you didn't pass the exams, or if you scored very low and you want to write the receipt, or you want to do anything, I don't know. Yeah, that you get a chance to do a receipt. Okay. So don't think it's the end, or you don't panic if you didn't pass the exams. All right. You'll get a chance to do the receipt. One of these Fridays, we'll book a receipt for you guys so that you can do it and then you can pass the exams. Okay. Now that the whole course is still fresh in your head, you can pass it. You can do it and pass it. Those of you that did not pass the exams. So that's what he has asked me to tell you. So, okay, right. We shall continue our lesson. It's this one. Share. Okay, so are we going to do it for all of them? I think we should do for number 3. Don't worry about the other ones. Find the number of faces, edges, and vertices for each of the 3D shapes. Not all, just do it for number 3 for me. Maybe one of the other ones will be for your homework. And he said that our Moodle course is ready on Further Maths. So I'm going to have a look now. Yay, engineering, Further Maths, yes. So we are ready. So I can start to put some stuff for you there. By the end of the week, when we have finished topic 1, we can put stuff for topic 1 in there. I will try and make it simple this time so that we don't get stressed out before the exams. Good, 6 faces. Well done. Keep it going. Okay. Well done, guys. You're doing good. Everybody seems to be writing different stuff anyway. So, well, you all agree on the number of edges, but faces are a little bit different. How many edges and how many vertices rim? Ariam, I'm not getting any information from you. I'm not getting it on the chat. I'm not getting you. Can I put this on Moodle? It will be on Moodle for you, okay? The video will be on Moodle. 24 edges. Okay, we'll see now. Okay. All right, guys, let's have a look. Let me see who else is putting stuff there. Oh, Naji. Ah, now you got it. Okay. Okay, we'll see. We'll see now. So let me share this on Moodle because I think PowerPoint. It's not my PowerPoint. I don't have the right to put it. I use them. It's the thing that I'm signed up for. Yeah, but I can only use them to teach. I can't put them, I can't use them. Yeah, I hope you understand what I mean. I don't have the copyright for them. You understand? Thank you. I only use them to teach you because I have access to the resources as a teacher. Okay, guys, let's have a look at the answers, okay? For the first ones, I didn't get us to do those ones. We're looking at the third one. So the third one is 6 faces, 12 edges, and 8 vertices. Well done to all of you. Those of you who got it right, well done to you. I think we've done it for the, have we done it for Q? I think we have. Let me see. Okay. Find the number of faces. Well, that's the same one we've just done. We've done these ones. Oh, it's like a worksheet that I can give to you guys. If you were in class, I would have printed this off for you to use it. So that's the end of it. Okay. Right. So that's what you need to know for that one. So you might get a shape in the exams, and I might ask you, how many vertices has this shape got? How many edges has it got? How many faces? So you need to know how to get them and how to get it right. Yeah. Okay. Hamad, you're a little bit quiet today. What time is it? 9:43. Okay. Okay, so I'm going to tell you, let's have a look at Euler's work, yeah, about a mathematician known as Euler. Yeah, there he is, Leonhard Euler. Is one of the greatest mathematicians that ever lived. Yeah, his name is Leonhard Euler, and he did some work with 3D shapes, and he tried to form a relationship between the faces, the vertices, and the edges. Yeah, he tried to create a relationship between the faces, the vertices, and the edges, and he came up with a formula which they call the Euler's formula. Yeah, it's spelled Euler, but it's pronounced Euler. Yeah, as in. Okay, no problem. Yeah, it's spelled Euler, but it's pronounced Euler, as in Euler. Okay. Yeah, but his name is this one. That's how it spells. Yeah, but he's one of the biggest mathematicians that ever lived, you know. So here goes Euler's law. So if you have a look at the first one here, you have the face, number of face is 4 for this one. It has 4 faces, it has 4 vertices, and it has 6 edges. Yeah. And the next one, it has 5 faces, 5 vertices, and 8 edges. Yeah. And the next one is the number 3 one. It has 6 faces, 6 edges, 6 vertices, and 10 edges. So can you see what is happening here? Can you build any relationship with them? This one has 7 faces, 7 vertices, and 12 edges. But this one has 6 faces, 5 vertices, and 9 edges. Is it number 5? Oh, I'm going the other way around. It's number 5 here. Yeah. So let's have a look at what Euler is trying to bring to us. Yeah, so let's find the connection between the 3 things. Yeah. So the edge is equal to the vertex plus the face minus 2. Yeah. So write down a couple of those from the table, maybe 1 to 3 or 1 to the right, some of them down. Yeah. 1 to 3 or 1 to 4, however many you can write, and then write down the formula. So that's the relationship between the faces, the vertices, and the edges. You can take a screenshot of all of them if you want to. Well, this will be on, but you can write some of them and you can put dot, dot, dot at the bottom. Yeah. Let me know when you finish writing.
Miss, sorry, what do you want us to do?
I want you to write, so write this table, but you're not going to write everything. So you write the first couple of them, number of this first one, yeah, vertices, faces, and edges. Maybe you write the first, second, and third one. Then you write the formula down. Write down the formula. Okay. So write all of them. Write the formula down. I think the first one is a triangular base pyramid. So instead of writing number 1, you can write a triangular pyramid. And instead of writing number 2, you can write square pyramid. And pentagonal pyramid. And so on. Let me know when you finished, okay? Have we finished?
Yes.
Okay. Okay. So that's what you need to know about that. Yeah. You need to know about Euler's formula. And if you're given one thing or the other thing, yeah, you can use it to find the other ones. Okay, so for example, if you get the vertex and the face, you don't even need to know what the shape is. Then you can just tell what the number of edges it will have, yeah, by using this rule, this formula. By rearranging that formula, you can work out how many edges it will have or how many faces it will have based on what you've been given. Yeah. Okay, so I think that's it for that one. And so let me go through this with you. Euler was a Swiss mathematician whose power of mental calculation was prodigious. As a teenager, his fame quickly spread throughout Europe, and at the age of 20, he was summoned by Catherine I of Russia to study at the Academy of Science at St. Petersburg. He became professor of physics at 23 and professor of mathematics at 26. At the Academy, he contributed to numerous branches of mathematics and other sciences, including work on optics and the study of planetary motion. He made progress towards solving Fermat's last theorem and introduced the notation for pi and sigma. At 31, he lost the sight in his right eye and later became almost totally blind. He had 13 children, of whom only 5 survived their infancy. His life's work of 886 books, papers, was still being published 50 years after his death. Okay? So even after he died, people were still publishing his work. So at least you've learned a little bit about Euler, and you've learned about his rule and his work with 3D shapes. Okay. So I think I have another PowerPoint I want to share with you on 3D shapes. Let me see. Is it even 3D shapes? Escape. Okay. Let's have a look. What else did I open up here? Okay, thank you. Okay, so this will, let me share the screen with you guys. This would just be talking about rotational symmetry. Yeah, I think we started to talk about lines of symmetry yesterday. Yeah, with 2D shapes. We talked about lines of symmetry. So we're going to have a look at that now. Yeah, I'm going to show you. I think yesterday I bombarded you guys with a lot of information, but today it's going to be more chilled out and we're going to have a look at it more graphically and enjoy it instead of just like having things thrown at us. So this is all about symmetry. Okay, it's called rotational symmetry. So how many times can something come back on itself? Now, this is not a line of symmetry where you are folding things. This is when you rotate something, how many times does it come back onto itself? Yeah, so it's called rotational symmetry. And it's not about a line of, it's not about folding something and getting a line on it. It's about rotating something and finding out how many times that thing can come back onto itself when you rotate it. Yeah. So I don't know what example I can give. So if this is my phone, for example, if I rotate, now this phone is looking like this vertically. If I rotate it this way, it's gone into a different shape. That is 90 degrees that I've rotated it. But when I rotate it again this way, then it's come back to itself. So that is 180 degrees, 180 degrees turn, and it will come back into itself. Yeah. So different shapes have different number of rotational symmetry. Yeah. So let's have a look at what's on the PowerPoint. Present. Okay. So we're going back to 2D shapes from yesterday. Yeah. So all 2D shapes have some rotational symmetry, which I've told you about. It's when you turn something, how many times you can turn it before it comes back onto itself. The degree of rotational symmetry that an object has is known as its order. Okay, so order of rotational symmetry, you can have, this one is only one time that you can have it. Yeah. For shapes that have order 2 rotational symmetry or higher, a single center of rotation can be located. Yeah, so just like I demonstrated with my phone, this is one that you have to go to one time before it can come back to itself. You have to rotate it one time fully before it can come back onto itself. But this one, you don't have to rotate it. Like if you do it once and twice, then it can come back into itself. But some of them, you have to do it full 360 degrees turn before they can come back onto themselves. Yeah. The order of rotational symmetry that an object has is the number of times that it fits onto itself during a full rotation of 360 degrees. Yeah. So let's see. So this one has to go round 360 degrees before it can come back onto itself. This one, I think it's maybe twice, because if you bring it down this way, it probably will come back to itself. And this one is 3 times. If you turn it, this will be 1, and turn it again 2, and turn it again 3 times. Yeah. And probably this flower would be 4 times, because when you turn it, the first one, it will come back onto itself. You turn it again, it will show you the same shape. You turn it again, it will show you the same shape, and 4 times before it will show you the same shape. Yeah. 4 times it will show you the same shape. Now this is the hard one. I think it might be 5 times. I don't know. 1, 2 is 5. Yeah, because it's a regular pentagon. Yeah, it's a regular pentagon. We said that yesterday, that all the regular pentagons, they have Yeah, the number of sides they have is the number of lines of symmetry that they have. Yeah. This will be 1, 2, 3, 4, 5, 6, probably 6. Yeah. Okay. What do you think this one would be? It's an equilateral triangle. What do you think the order of rotational symmetry for that one will be? Let me know in the comments. Let me know in the chat. Yeah. So I'm going to talk about pyramids and prisms. Abdullah allows. You think it's 4? Okay. Should we see?
Yes, do you mean symmetry lines or what?
It's when you rotate it, how many times before it comes back onto itself? So, right, let me come in with my phone. Let me come in with my phone, guys. I think maybe you guys, you need to see this. You don't want me, I don't want to be like, this is my, let me come in with my phone. I can show you. Where are my start messages? Join with video. Yeah. So, cancel. Let me turn this upside down. I'm going to pin that video so that you guys can see it. I'll share. Okay. So if I it's not showing. Let me see. I want to pin that video. Gallery. Oh, it's here. Pin. So if I have this, for example, now, and oh, it's upside down, showing you upside down. So I have this rectangle, yeah? If I write 1 here, and 2 here, and 3, and 4 there, yeah? Watch now. If I turn it once, it's gone back onto itself 1 time. And it's come back onto itself another time. So that is twice. Okay, that is 2 times. So it's order of rotational. I'm rotating it. Yes. I'm rotating it and I'm finding out how many times it can come back onto itself when I'm rotating it. Okay. So right, what I need to do is maybe I need to put 1 under, yeah, and show you. So watch now. So there's 1 under, okay, so that you will see how many times it overlaps with that one. So if I turn this one on top, 1 time, you see it's not overlapping. And then the first time it overlaps is 1, yeah. Then I turn it again, rotate it again. It doesn't do it this time. And here's the second one. So there's two order of rotation 2 on this shape here. Okay, my phone is dying, so let me take it off. Okay, guys, I need to charge it. Leave meeting. Okay, so do we understand it now? So you're rotating it and finding out how many times it comes back onto itself. That's what it means. What we were doing before is reflecting it. So reflection is like it's when you fold it, how many times does it come back? How many times does it how many different ways can you fold it so that you have the exact same shape on both sides? That's reflective symmetry. But now I'm teaching you rotational symmetry. Do you understand? And that is different from reflective symmetry. What we were talking about on 2D shapes yesterday was reflective symmetry. When you can draw a line and then it will divide the shape into 2 equal parts. But today is how many times, if you rotate that shape, can it come back onto itself? Yeah, that is rotational symmetry. All right. Okay, so let's see. Let's go back to the PowerPoint. Guys, I don't want to be wearing my glasses because it's just going to finish my eyes for good. So this one was 3 times, you know. If you put a triangle on that shape there and if you label it 1, 2, 3, you will see that, or you put a dot on it, you will see that maybe when I charge my phone tomorrow, I'll demonstrate this thing to you guys a bit more. I'll get a scissors and put a dot on one of the triangles and show you. So let's try another one. So of course, this one is going to be, how many times do you think this one will be? Rotational symmetry. How many times will I rotate it before it will come back onto
1.
itself? Well, 1 is not going to be enough. Imagine that you're rotating it 360 degrees. Yeah. Imagine that you are turning this square 360 degrees, full turn. How many times will you get it onto this shape here in that particular spot? Infinity? No. Infinity? No. If you do a 90 degrees turn on it, you're going to get it on itself, back on itself. If it's a square, you will get it back on itself. Let me get my scissors. I think I need a scissors for this topic, and I need to charge my phone. So I'll get my phone to charge, and after the break, we can explore this a bit more. Yeah, let me go charge my phone and get the scissors and cut it off, and maybe I can get you guys to look at me while I do it. Well, I couldn't find my. Well, what may be worth doing is to see whether we can find a video online that demonstrates that. Yeah, share that one. Yeah. Okay. Let me just search for it so that maybe we can find something that will show it. An animation type of thing. Rotational symmetry. Animation. Yeah. Let's have it correct. Yep. Okay, I think these guys, they have it. Yeah. Okay, watch. This one, watch this one. Let's play this one. 1, 2. Have you seen it? So it's a full 360 degrees turn, but it will come back onto itself at 180 degrees, and then it will come back onto itself again at 360 degrees. Watch. 1, 2. Watch where it's starting from. Look at where it's starting from, and look at when it gets here, it's back to itself. Then when it comes back here, it's back to itself again. So watch again. 180 degrees, 360 degrees. Do we understand it now?
Yes.
Okay, I'll play this one now, and you see how this one is 3. Watch where it's starting from and see it. 1, 2, 3. So when you rotate it, it will take it 3 times. So it will come back onto itself 3 times before 360 degrees, by 360 degrees. Okay, so that's what rotational symmetry is all about. So you have to think about it to see how, how that thing is happening, what's going to happen to that thing if you rotate it, and how many times does it come back onto itself. So let's go back to the one that we were experimenting with. And let's see whether we can get it right. And then we can go for break. And when after the break, we can continue. So that was 4 times on this one. So let me get us. So how many times do you think this one will happen? It's a regular pentagon. No. No, guys. Think about it being rotated. So let me draw one on top of it now, yeah? I can draw another one on top of it here. Let me see. Let's see now. By the time it gets here, it will be back onto itself once. Yeah. And when it gets here, it will be the same thing. And when it gets here, it will be the same, because it's all equal sides and here. So it will be 5 times. Okay, guys, we continue after the break, all right? So that you guys, you don't feel overwhelmed. And you don't say, oh, it's too much information. You bombarded us. Well done, Naji. You got that. That's 5 times. Okay. We'll come back at, when are we back now? We're supposed to be on break at past. And come back for, no, that's 30 minutes break. It's too much. We should be learning. It's too early in the morning to be taking such long breaks. 1, 2, 3, 4, 5. Says 5. Well done to you guys. What about this one then? A regular hexagon. Six. Okay. Well done. Well done. So if it's a regular shape, you know the drill, because if it's a regular shape, it will be the number of sides. But how about a rectangle? What do you think will happen with a rectangle? How many times will it take it for it to come back to itself before 360 degrees? I demonstrated this one for you guys, so you can't say you don't know it. Not quite. Not quite. A rectangle, think about it now. Yeah, think about it. If I turn it this way, when it's up like this, is it going to come back onto itself? Nope. And this would be 90 degrees, yeah? If you turn it like this, back onto itself, 90 degrees, it will come like this. But when you go 180 degrees, it will be like itself, this one. Then you go 270, when you are here, it will be yeah, so it's going to be 2 times. I don't know if you guys can see it. It's hard for you to see it if you don't have something in front of you. But how you check it is you make the shape, or you make 2 of the shapes, and you see how they put a dot on it. You put a dot somewhere and see how many times, or you number them. Okay, maybe you put the dots there and put the number there. Yeah, and you see how many times it comes back on itself by rotating it on that same shape. So I think a rectangle will be twice. It will be 2 times. 2, yeah? Rotational symmetry. Okay, I think this one is the one that we have to do when we come back after the break, okay? Okay, 10 minutes is all right. So you guys can go. I'll put my video off and put myself on mute, and we can come back at 1:45. Yeah. If you have any questions to ask, feel free to ask them, okay? I will be here until the break time. Hmm. Okay, let's have a look at the register. Lectures. Foundation Maths 10:45. Scheduled. Okay, so listen to your names, guys. Please answer when I call you. Abdullah Aloud.
Yes.
Naji.
Yes.
Abdurrahman Alanazi.
Yes, teacher, I'm here.
Ariam Alanazi. Ariam. So not here. Hamad.
Yes.
Reem. So not here. Ibrahim Al-Majed. Khaled Al-Osaibi. Abdurrahman Al-Shamri. Odeibi Madi. Khaled Balji. So who are the people here then? 1, 2, 3, 4, 5. Okay. So I haven't got Ariam, Reem, Ibrahim, Khaled, Abdurrahman, Odeibi Madi, and Khaled Balji. Okay. So let's continue from where we were, what we were looking at before the end of before the lesson ended, okay? At the first half of the lesson. So let me just take you through stuff, yeah? I think here I had on this Maths is Fun. It's a really good website for maths. We had geometry there. And I think the ones to do with 2D shapes are plane geometry, and the solid shapes are 3D shapes, or 3D shapes are solid geometry. So this is what we were doing from yesterday till today. Yeah, we had a look at, I've told you that a line is a one dimension, 2D shape is a plane shape like a square, rectangle, and we have 3-dimensional shapes, which is a solid shape, yeah? So 1D, 2D, and 3D. And we even have 0D, which is a dot, okay? I think Reem would like to see this, so let me wait a little bit. Yeah? So I'm just going to mark you in now, Reem, because you've just come in. Okay. So I was just saying to the rest of the class that this is everything that we've been looking at. Yeah, so you can have a point, which is no dimension, and you can have a line, which is 1 dimension, a square, a rectangle, a circle, which is 2 dimension, and you can have a solid shape, which is 3 dimension. Okay, a plane shape is 2 dimension, a solid shape is 3 dimensions. Okay, and yesterday we looked at triangles, right angle triangles, all different types of triangles. I told you about isosceles, equilateral, scaling, yeah, and okay. So I haven't gone to that extent. And I told you about right angle triangles, yeah, the one that has a 90 degrees thing on it, yeah. So we'll look more in details about that when we come to do trigonometry, because we'll be doing Pythagoras and trig maybe next week, yeah. And I told you about quadrilaterals, rhombus, parallelogram, all those different ones, yeah. So Here's something that you can play with if you want to make a kite. You can see all the different angles, the sides and the diagonals. If you want to put a square, it's going to show you what a square looks like, a rectangle, a rhombus, and the trapezium. It's going to show you all of those things. I told you about about quadrilaterals, that they have 4 sides, 4 vertices. They have, okay, also the interior angles add up to 360 degrees. Yeah. So different types of quadrilaterals. I told you about kite, parallelogram, rhombus, square, rectangle, trapezium. So you learned all of those things from me yesterday. Yeah, it may seem fast, but we looked at them and the video is there. You can always go back and look at them. And if you're not sure, I'm just showing you this lovely website that has covered the entire curriculum. Actually, I didn't even see this website before I started teaching you guys. Yeah, so. Okay, and we looked at polygons as well. Yeah. Okay, so let's go back to the other page. And I said that tomorrow will be for area and perimeter and maybe volume from 3D shapes. Okay, let's have a look at what we've done so far with the solid geometry with 3D shapes. Yeah. 3-dimensional shapes. I told you it's got weight, height, length, width, and height. Yeah. So you can have all the different shapes: sphere, cone, cuboid, cube, cylinder, and all the rest of them. Yeah. And this is going in depth now. Polyhedra, I haven't taught you about polyhedra. There's lots to do with those ones as well. So I've taught you about vertices, faces, and edges. Yeah, so you know about them. And you know about Euler's theorem. Okay. Euler's formula. This is the formula that you wrote down. F plus V minus E is equal to 2. We wrote this in a different way, but it's the same formula. So on a cube has 6 faces, 8 vertices, and 12 edges. So you will have 6 plus 8 minus 12 is equal to 2, which is correct. Yeah. So I haven't told you about Platonic shapes, so I'm not going to go into that. Yeah. Okay. So that's that one. And we were looking at, I think we're looking at symmetry, isn't it? That's what we're looking at, rotational symmetry. Okay. So we're looking at rotational symmetry. Is this one? Okay. So how about the parallelogram then? Let me do the presentation. How about a parallelogram? You can get the scissors and you can draw that shape and try and work out how many times it comes back onto itself. Yeah. Or how we do it is you draw the shape on a piece of paper, then you take a transparent paper, like maybe what do you call that one now that you put papers inside? Polly pockets. Yeah. You take a Polly pocket. Let me see if my phone is charged. Okay, let's see if my phone is charged. If it's charged, then it will be a great idea. I can come in with my phone and show you guys how you find out these things. It wasn't even plugged in, and now I can't even find it. So, oh yeah, it's here, so I can plug it in now. I found the charger. Right. This place is packed full with stuff. No, I'm just gonna go put it down on my back. So maybe I can do it with my actual, I can pin myself and do it with my actual webcam. Let me see. Let me see if I can pin myself and come in with the webcam. Right, where is the thing now? Is this one? Oh, it never works. Let me pin myself. Pin. And maybe I should stop the share and then I'll demonstrate this to you guys. I'll be back. Let me get cling film. No, Polly Pockets. Yeah, Polly Pockets. That's what I'm looking for. Actually, I have it here. Oh, it's in the other drawer. So I've got here. What have I got here? Let's see. I wish I could get one of something high to put this thing on. Let me get my lights. I don't know where to put it. So this is my sheet of paper, and I've got a Polly Pocket here. I don't know if you know what this is. Polly Pocket. Up here. Okay, so now you can see me better. And you can try this out yourself at home, yeah? So you just draw that parallelogram. Sorry, it's not going to be the best. You draw the parallelogram, like, let's draw it something. Okay, there we are, I've drawn it. And then you put a Polly Pocket over it. Maybe you can label the sides. If I call it A, B, C, and D. Yeah. Sorry, because I'm doing everything with my hands. I'm kind of all over the place. And then you put this one on top of it. Okay, and I think you can kind of hold it down with in some kind of way, and then you label this on top of this one: A, B, C, and D. And if you rotate this one now, if you rotate it, that didn't draw. Let me use a different color pen. A, B, C, and D. I'm just going to draw that. And it's not going to be perfect, but at least you will get what I mean. And draw this one. Yeah. Then if I rotate this one, there you guys, you can see that it's never going to come back onto itself until this is the first one. Okay. Let me see. Let's start from the beginning again. So hard. No, I have to get something to place this thing so that I can show you this, because I want to show you. I really do want to show you, but it's so difficult. I'll use my stand. I have some stands here. I have a light stand here. The one that I use for my YouTube. Let me lift that up a little bit. This is how other teachers struggle to just to explain something. You have to wrangle your way so much, just because math is such a technical subject. There are certain things I can't just be saying them like randomly. You have to see what I mean. Let's see. Can that work in any sort of way? I'm going to put something on top of it. It has to work. You have to work, man. Yay! Okay, so so we got this here. Now that's the original one that I drew. Okay. I'll get okay, this is a green one. Okay, I have A, B, C, D there. And then I'm going to draw it on my Polly Pocket. How did I even draw that? I think it was this way, yeah. I'm going to draw that on my Polly Pocket. Okay, and label them, okay? So this is going to be A, B, C, D, okay? And if I draw that again, if I draw it again, let's say this is where we are starting, and this is the 180 degrees, and this is 90, and this is 270. Let's call it that. I'm going to put that in the middle. I'm going to turn it which way? This way. Okay. It doesn't come back onto itself. You see that one? It doesn't come back onto itself. Okay, I'll try it again to 180 degrees. Now it comes back onto itself to 200. That's one to 270 degrees. It doesn't come back onto itself. Yeah, and to 360 degrees. That's another one. So that's 2 times. Yeah, so that's 2 times on the parallelogram. Okay. Let me share my screen and let's see what they have to say to us about parallelograms there. So rotational symmetry on here is only 2 times. Yeah, so only 2 times that it came back onto itself. How about an isosceles triangle? You guys have to think about this one now because I'm not going to do it for you. I want you to tell me in the chats how many times you think an isosceles triangle will come back onto itself. Think about the shape that is under, and if you turn it, how many times do you have to turn it before it comes back onto itself? Let me know in the chat. Even if you're not sure, you can guess something, okay? If you're here, put it in the chat for me, please. Well done. Well done. I've seen 2 nice answers. Okay. Naji, okay. Okay, even if you're not sure, make a guess. 2 times. Okay, let's see. Well done. Well done, guys. So, well, I feel that it will be 2 times. I don't know. I feel that at 180 degrees, it would have come. No, it won't. It will be facing the other direction. No, it won't. It will be 1 time. Yeah, the boys are right. It will be 1 time. Yeah, because every time you turn it, it will be facing a different direction. Yes, it will be on Moodle. Yes, Khaled. Yeah. Every time you turn it, it will be on a different, it will be facing a different, unless when it comes back full 360 degrees. Yeah, so 1 time, guys. Yeah. Okay, how about this one? How many times will we turn this one before it comes back on itself? Have a think about it. Yeah. Well done, Abdullah. You're right. Well done. Oh, well done, Reem. Well done to you guys. You can do it now. You're well done to you. Yeah, you are showing more understanding of it now. Okay, let's see how many they have. 1 time. Yeah, because it's only 1 time. If you rotate it, that it will come back onto itself. This one would be like the isosceles triangle, I think. It's probably going to be only 1 time. Yeah, it's 1 time. And this one. We'll finish it off and then we can have a look at similarities. This will be 1 time as well. Now, how about this one? How about a rhombus? Might be like the parallelogram. Remember the parallelogram? It might be a little bit like it. Not sure. But think about it. Well done, Naji. Yeah, well done. I think by the time it's 180 degrees, it would have turned back onto itself. This place would have been down here and it would be the same thing. So I think it's 2 times. Yeah, well done, Naji. Ha. Now this one is 2 times. Yeah. Well done, guys. So look at all of them, all different shapes with different orders of rotational symmetry. Yeah. So I will leave the link, of course, to the video on Moodle, but you're not going to get. Let me see. Have we finished? Yep. I think that's the end of the slides. Okay, there we go. Right. Let me remove my webcam and put it in the right position. You guys, you won't believe what I did here to get this to stay here. I've had to use my filming lights. Okay. Let's put that there for now. this one and take this one back to where it came from. You guys, you have learned a lot between yesterday and today. You've learned so much. I mean, you've covered almost like a lot of the things that people do from primary to secondary school. Yeah, about 2D shapes. So we're going to give it a wrap now. We're going to do a little bit of, we're going to find out the difference between, let me stop the share. We're going to find out the difference between pyramids and prisms, okay? The difference between pyramids and prisms. Then we're going to look at similar shapes, okay? Right. So you know all about shapes, and because what we had in our old curriculum, we didn't have any geometry whatsoever from NCC. So when our students go to uni, they complain that when they give them work, especially those going for engineering and all the technical work, they don't have any knowledge of geometry. So now you know everything about geometry. Okay, I'm just gonna give you guys a quick check of your knowledge, a quick check of what you know, okay? I'm going to draw a triangle and you tell me what type of triangle it is, okay? Clear all my drawings. What type of triangle? Oh, my drawing is so bad. What type of triangle is this? In the chats for me quickly, guys.
Miss, what do you want us to do?
What type of triangle is it? What type of triangle? I know it's a triangle. What type of triangle is it? Well done, Naji. Oh, no. I called the wrong person. Well done, Reem. Naji, try again. Oh. It's an isosceles triangle. Yeah, how do I know? It's got 2 equal sides and 2 equal angles. Okay, so that's an isosceles triangle. How about this one? What type of triangle is that one? Well done to you. Abdullah Laos. Well done. Okay. What type of triangle? Oh, this one is an equilateral. Okay, equilateral. What type of triangle is this one? Well done, Abdullah. Well done, Reem. So this one is a scaling, okay? Scaling triangle. And of course, this one is a giveaway now. What type of triangle is this one? Everybody should know this one. You should all know this one. And I don't want to hear anybody saying, I don't understand. We haven't done any maths today, no calculations today. We are just learning, okay? So we should enjoy it. Okay, this one is a right-angled triangle, yeah? It's right-angled. Well done to you guys. So this one is right-angled. Now, when it comes to the 3D shapes, there are two different types of 3D shapes that you need to know, okay? Two categories of 3D shapes that you need to know, okay? You need to know the prisms, and the pyramids, okay? Anybody from Egypt here? Egypt, lift your hands up. No Egyptian in the house? Ah, no Egyptian. Oh, dear me. Oh, you live there. Well done. At least we have somebody representing Egypt for the pyramids. Oh, you lived there. Well done. Did you go to visit the pyramids? I wanted to take my children to visit and see the pyramids before all this trouble started. The trouble in Egypt before even COVID. I think there was a little bit of trouble then before even COVID started. So we didn't go. Yeah. I would love to go and see the pyramids and walk in the desert and all that. Okay, so you know what pyramids look like. I'm not going to tell you about them. Okay, so pyramids are the ones that have faces that meet at a point. Okay, pyramids have faces that meet at a point. And we've already learned so much about them. Yeah, we've already learned a lot about them this morning. We learned about the triangular base pyramid, the one that has a triangle on the bottom. Yeah. And we learned about the square base pyramid. And we learned about octagonal pyramid. And the one thing that is common between all of them is, as you can see, they all meet at a point on the top there. Yeah. So they are all pyramids. All of them that meet at the top there are called pyramids. And including this one, but this one would be slightly different. It's in that category, but especially called a cone. Yeah, we won't call it a pyramid, but it's in this category. Yeah, but it's called a cone. So we differentiate it from the other ones. Because it has a circular base, yeah? It has a circular base. Okay, the special name for this one is tetrahedron. All three, yeah? 3 sides, 3 faces, tetrahedron. And I think they are all called polyhedra. Polyhedra. And this one is not among because this one is not a polygon. It's not, okay? So, right. And then we have the prisms. With the prisms, you have a constant cross section. Yeah, you have a shape that has a length and a constant cross section. Okay, it has maybe you have yeah, So this would be like if this was a loaf of bread. Now you can take slices, thin slices that will look like rectangle, and those rectangles go all through the length of that bread. Yeah, the rectangles go through. Think of it as a bread that has sliced bread. Yeah, with all the rectangles going across the sliced bread. Yeah, so that's what prisms are. If you have a cylinder, it's kind of in that category, but it's like a little bit like this one. Yeah, a cylinder it falls under that category as well. So if you cut them into thin slices, you would have all these circular slices. Yeah, the cross section is a circle, and here the cross section is a square or rectangle, a rectangle. Yeah, so you can say this one is a rectangular prism, a rectangular prism. Yeah, so it's a circular prism, because you can have a triangular prism as well. So you have the triangle, the face, then you will have it going long like that. Yeah, so that would be a triangular prism, because you can have slices of triangles all across that. Yeah, if you decide to slice them. So do we know the difference between prisms and pyramids now?
Yes.
Yes. Because pyramids, they meet at the points at the top there. Prisms have a cross section, a face that goes across the length of that shape. Yeah. Okay. Now let's do some maths before we before we come to the end. Let's try and do some maths. Come now, I'm looking for my worksheet. I think it might be in. Okay, let me see if I have a PowerPoint on it. Here's my Google Drive. We can get rid of this one. We can get rid of this one and this one. Similar. Similar shapes. Similar triangles. Okay. Let's see what's in that one. Stop share and share screen. Okay. I know they're talking about triangles, but it's similar shapes. Yeah. Yeah. These two triangles are similar since they are, well, what is equiangular? Let's go back to the back one. Okay. So if you have, you can use the knowledge of similar shapes to find missing angles, to find missing sides on the shapes. Yeah, you can use the knowledge. Let me just write that example down, and I can explain it to you guys. So you can say that shapes are similar if they have the same angles. Okay, equal angles or the same angles. Let's put equal. Let's use the right word. Equal angles. Yeah. And if the sides are increasing or decreasing, the size change in the same ratio. Okay, sides change in the same ratio. So what I mean by that is maybe you have this triangle and then you have this same triangle which has been expanded. Yeah. And if this is maybe 30 degrees and this is what 70 degrees and this is 80 degrees. It's the same thing on this one, 30, 70, and 80. Yeah. But when you come to the sides, this one is 2 centimeter, and this one is 6 centimeter, and this one is 3 centimeter, and this one is 9 centimeter, and maybe this one is 4 centimeter, and this one is 12 centimeter. You notice that the ratios are the same on, it's increasing. This triangle is times 3 of this one. Yeah. So here is 6 times 3 is 2 times 3 is 6. 3 times 3 is 9, and 4 times 3 is 12. Yeah. But all the angles are equal, but the sides are changing in the same ratio. Okay, here is times 3, it's times 3 here, and it's times 3 here. Okay, so that's what we mean by similar shapes or similar triangles. I know I'm using triangles, but it can be any shape really. So you can use that knowledge when you say that the shapes are similar, then you can use that information to work out missing lengths on the triangles or on the shapes. Yeah. So let's look at the example that was on that PowerPoint. Hope you've written this down because I want to take this one off. So if you have if it says that triangles A and B are similar, find the missing lengths. I'm just going to rub off this part. So let me draw the triangles. This is triangle A, and you have this part to be 15 centimeter, and this part is 20 centimeter, and this is B. Okay, and this is triangle E, and this part is 6 centimeter, and here is C, and here is 12 centimeter. Okay, if the two shapes are similar, then it means to find out any of the missing sides, we have to use our knowledge of ratios. Yeah, so 15 over 12 would be equal to 15 here over this one would be equal to this one over this one if they are similar. Okay, would be equal to 12 over C, 15 over 12. Make sure that you put them in the same order. If you did this one as 15 over 12 is equal to 20 over C, not 12, 20 over C. Now you can cross multiply to get rid of the fractions. Yeah, 15C would be equal to 10 times 12 is 120, so double that would be 240. Yeah, and C would be equal to 16. Okay, C would be equal to 16. I'm just going to confirm that now. Thank you.
I have one question.
Yeah.
A and B are they similar?
A and B are similar.
So
They are
why
similar
from
shapes.
from the bottom we have 12 and 15?
Why what?
Similar shape, not similar length.
Yeah, okay.
Okay.
Do you understand now? So we
Yes,
got our,
I thought similar length.
oh, okay. So we got our C to be equal to 16. Now we can try and find B. Yeah, we can try and find B in the same way. So we want to find this one and any other two. So we can say 15 over 12 is equal to B over 6. Yeah, and then we can cross multiply. 15 times 6, 15 times 2 is 30. 15 times 6 should be 90. Is equal to 12B. So what is B then? Well done. 7.5. 7.5 centimeter. Do we understand? And we would have done this in secondary school anyway. Okay. This is not all the things I'm teaching you people so far. I haven't put any further maths in it. This is all year 6, year 6, year 7, year 8, year 9, year 10 stuff. Yeah. I haven't put any further maths or A level into it. So maybe from next week we can see. By the time we finish Pythagoras and trig ratios, and we begin to go deeper into it, we'll see. All right. So write those down and let's see whether we can get one from my PowerPoint, 1 or 2 from my PowerPoint to do. Write my example down. Okay. Have we written down?
Wait, miss.
Okay. Let me see if I'll get some similarity questions in my textbook.
Yeah, miss, I have finished.
Okay. 157, 168. I'll be there now. Okay. Clear all drawings. Stop share. Share screen. This one. Share. Let me do the presentation. Present. So that's the one that we've just worked out, okay? This is how they cross multiplied and they worked out the B to be equal to 7.5 and C to be equal to 16 centimeter, okay? Okay. Here's another example. Oh, maybe you don't need to write all the examples down. Did they give us any one to do? Nope. Nope. These are all getting more complex without basic examples. Okay. Oh, actually, this would have been a nice one. Present. Did it? Oh, I don't like how they just jump straight into the. Did they give us any one to do? Into the solution. No. Okay, I'm just going to use my notes then. Share screen, whiteboard. Share. Okay, so let's have a look at this one. You have these two shapes. Let's do one at a time. You have this shape is this one 2.6 centimeter, 3.2 centimeter, and you have B here to find, and then you have this shape. Here it is 5.2 centimeter. You have A to find here and 9 centimeter. The two trapeziums are similar. Find the lengths A and B. Okay. Would you know what to do here? It's the same thing as we did. You find the ones, because they are similar, you have to find the ratios, the ones that are in the same ratio. And then you put them together as I showed you, and then you find B and then you find A, or find A and find B. Oops, sorry guys. Okay, we'll see now. We'll see. Okay. Some people are finished already. Well done. Okay. So let's see how we did. I'll give 1 or 2. I'll give you guys maybe 1 minute or 2 to finish. Oh, well done. Well done, boys. So you have these 2 ratios here. You have these 2 here. This one and this one, which you can use those 2 to find out B, A or B. Yeah. So let's have a look at how we can do that. So 2.6 over 5.6 is equal to 3.2 over A. Yeah, so now we can cross multiply and then we can find A. 2.6A would be equal to 3.2 times 5.6. And A would be equal to 3.2 times 5.6 over 2.6. Yeah. 6.9, yeah, 6.89 or 6.9, 6.89. Let's call it 6.89. So A will be equal to 6.89. So now that we found A, we can still use this 2 to find B, or use A and this one to find B. So let's choose one. Yeah, let's use the same ones we used earlier. So 2.6 over 5.2 is equal to B over 9. So 5.2B is equal to 2.6 times 9. And then B would be equal to 2.6 times 9 over 5.2, which is equal to what? Let's put that into the calculator and confirm your answers for you boys. 2.6 times 9 divided by 5.2. 4.5, yeah? So well done to you guys. 4.5.
Miss, I did it another way, but I got the same answer.
How did you do it?
5.2 and
Yeah.
And 9 on top and
Yeah.
2.6 and B on the bottom.
Excellent. Oh, 5.2 and 9. 5.2 and 9.
5.2 over 2.6.
6. Oh, yeah. Yeah. That works. That works.
Okay.
As long as what you have to do is make sure that if you start from A, then do it A over B. Then if you start from, let's use X and Y. If you start from X, it's X over Y. X over Y is equal to X over Y, okay? So because sometimes people mix it up. Yeah. That will still work. Well done. So let's look at a different example. Clear all drawings. Clear. Okay. So here's another example, slightly different one. Kn is parallel to Lm. I told you what parallel means yesterday, didn't I?
Yes, you did.
Okay. This is Kn, and this is Lm, and this is J. Okay. Here is 4 centimeter. Here is 4 centimeter. And here is 2.8 centimeter. And here is 12 centimeter. Work out the length of Kn. That's okay. Mariam. Okay, right. I saw you, but I was calling you, you didn't answer. So I guess that's much. I guess maybe it's either you were not there or your connection was giving problems. So would we know what to do with this problem? Could we attempt it?
No.
But if you look very well, you can see some similarity there. It's not showing, but you need to see. Yeah, there's the small triangle. There's a small triangle there. This one. And then there's the big one, the big triangle. Have you seen them? That are similar. So you can draw them somewhere else if you're not seeing them clearly and put those figures in. So this side would be 8 centimeter because it is what, 4 and 4 here, and this one would just be 4 centimeter for the small one. Here would be 12 centimeter, and here would be what? It didn't give us here, and it didn't give us here, but it gave us this one, 2.8. This side here, 2.8 centimeter. How is that though? If they are parallel. Yeah. So you can definitely find missing sides now. You can find the missing sides. You've been given some things there, yeah? You've been given 2 things there. You've been given this one and this one. Yeah. And now you have this one and you're looking for this one. How would you find it? That's NK, isn't it? That's NK. That's the line that's the one that's asking you to find. NK. Isn't that one this one? And this is ML. So you don't even need any other information. What you need, you got the information you need to work out that missing length. If they are parallel. It's my pen. I hope I don't break my pen. I just bought this one now, guys. Okay. We'll see now. Okay. Let one or two more try it and work their own answers out. We'll see now. Okay. Okay. So lots of you are getting it now. Yeah. So you look out for those type of shapes. They usually bring stuff like that to make you, but once they say it is parallel or they say it is similar, then look at it very well, and then you will find that they are similar shapes, and you can definitely use one to find the other. Okay. So we have this to this 4/8 is equal to what? NK over 12. 4 times 12 is 48. Is equal to 8 NK. Yeah. So therefore, NK would be equal to 6. NK is somebody's name anyway. It's a short form of somebody's name. Oh, right. You guys have worked so hard today. Do you want to keep on working or do you want an early finish?
I
Well
want
done
to
to
work.
you.
Okay, I
Okay,
want
okay.
early break.
Oh. Look, the women are stronger than the men in this class. Why?
No, miss, because we are studying, okay, at the beginning, easy stuff, and the end of the class, we're studying a lot of stuff.
Well, that is maths for you. You have to enjoy it. When you come, you'll be licking ice cream and drinking the sweets and tea and all that. Then towards the end, then they'll give you bones to crack. Okay, you have to crack the bones at the end. Okay. So instead of maybe I can give you guys 5 minutes. So yeah, everybody's saying early finish. So Rim, yeah, the only one who wants who wants to keep on working. Well done to you. You're a hard worker. Okay. Hmm. My lessons are usually like when I start off, it will look as if I don't know what I'm doing. Then I will get into a pickle. I'll get myself to a place where everybody's enjoying it and nobody wants to go anymore. Okay, let's see if we can work out this one. Okay. In the diagram, oh, let me use black. And I'm going to draw the diagram for you guys now. And when you finish this one, then we are free to fly, okay? This is V, this is X, this is Y, this is Z, and W. And you got 4 centimeter here, 5 centimeter, 2.5 centimeter. This one is 4.4 centimeter. Okay. So it's asking you to find XY, which is, XY would be this one, and VY, where's V? Oh, and this one. Oh, interesting. Okay, see if you can get those ones for me. Looks like there's somebody at my door. Let me check. Guys, I'll be right back. I don't hear the bell from this garage. How are we copying or managing? Are we doing good? Well, today was definitely much better than yesterday, because yesterday was, I just gave people bang, 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 bang. But today is much easier. Abdullah, why can't you finish? Why can't you do it? Okay, let's do it together, guys. Or are people working on it? So you're looking for X, Y. So the first thing I would do is I would bring out that triangle. Yeah. The small one, I'll call it 4.4, call it here 5. That one has all the sides even complete. So what's the problem? And then I'll draw the big one. And the big one only has this one as 7.5 because it's the whole thing, yeah? So I'm going to add them all up and call it 7.5. So we're looking for this one and we're looking for this one, yeah? So what's the difficulty there? You have this one and this one. Why can't you find the other one? You have this and you have this. So you can definitely find YX or XY, XY, yeah? So let me see. Well done, Reem. Yeah. Go on, guys. I cannot draw all the pictures for you because you have to draw them, work them out yourself and find out how to work them because you'll get them in your exam. 5 over 7.5 is equal to 4.4 over whatever that is, XY, okay? So 7.5 times 4.4 is equal to 5 times xy, which means xy is equal to 7.5 times 4.4 divided by 5. People are getting different answers now. Let me see. Okay, let's see. Let's put that into a calculator. 7.5 times 4.4 is equal to this divided by 5. I got 6.6, Rim. Yeah? Yeah. Or maybe you typed that in wrong. I don't know. So this is 6.6. So xy is 6.6. Now you got xy, you got this one and this one. You can find this one. Yeah? You can find this one. So you can use this two or use this two. What's this one? Vy. Yeah? So you can find Vy now. So let's do that. 4.4 over 6.6 is equal to 4 over Vy. 4.4 Vy is equal to 6.6 times 4. Vy is equal to 6.6 times 4 over 4.4. So you put that into your calculator and you should get the answer. And I got 6. Vy is equal to 6. That's what I got. Okay, guys. All right. So one of you is accusing me that I always start easy. And then I say it's going to be easy. Then it gets crazy. So guys, you just, with maths, you have to just keep on practicing. Whatever thing you learn, practice, practice, practice. You know, you use your Google. When you don't understand something, use Google. Learn it. Watch or read it in Arabic, read it in English. You will understand it. Like sometimes I go back and read stuff in my local language, in my mother tongue, so that I understand it better. And I come back to read it in English again. Yeah. So that I understand it better. And if you don't do your own independent research and practice, 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 find out what is holding you in understanding that topic or doing it. If maybe you cannot do multiply, practice multiply. If you cannot do divide, practice divide on your calculator. So that's how you study. That's how you win in maths. Yeah, it's not a subject you lie down on your bed and do. You have to be doing it. You have to be working on it. Yeah. Okay. I end my sermon. Stop. Oh my goodness.
No, miss, you didn't finish writing.
Okay, sorry. Sorry. Okay, you can finish writing now. Okay, I finished teaching, guys. If you have any questions,
Okay,
go
thank
ahead.
you, Miss. Have a
Yeah,
good day.
and you. Bye. If you want to go, you can go. If you don't want to go, if you have any questions, I'll be in the background until this time up, all right?
Okay, thank you very much, miss.
Thank you.
Have a great day. Bye.
And you. Bye.